Mr. Hissner here, and today we're actually going to be focusing on some more of these problems, these special right triangle problems, but these are going to be the ones that are a little bit more tricky, just so we can get a better feel for how to do these properly. So let us look at this first one here. So this first one, number 9, what's the issue with number 9? Well, as you can see, our reference triangle, we have the short leg, square root 3, the short leg, and then the hypotenuse, which is the short leg times 2, or 2 times the short leg. And the issue here is that our hypotenuse actually has the square root of 3 in it. And so here we have our hypotenuse is 22 square root 3. Well, what do we need to do to get to the hypotenuse from the short leg? Let me do this in yellow. To get to the short leg, to the hypotenuse from the short leg, we're multiplying. And then to get from the hypotenuse to the short leg, we must divide. So we multiply by 2. The opposite of multiply by 2 would be divides by 2. And this looks bad. But remember that whenever we divide these things, all we're looking to do is just divide the integers. Just treat it like it's a fraction. Treat this like it would just be 22x divided by 2. Well, what's half of 22x's? 11x's, right? So what's half of 22 square roots 3's? 11 square root 3's. And so for us, that means that our x value here is actually going to be 11 square root 3. So I'm just going to put that down here on my reference triangle. Okay, so now I'm thinking to myself, well, how do I get from my reference triangle, how do I get from the short leg to the long leg? Well, normally, right, we're slapping on, we're multiplying by the square root of 3. And so for us to get over here, we're going to have to do the same thing. And again, this is not ideal. It doesn't look good, right? This looks pretty messy. But when you remember that multiplication happens under the square root sign, that this is just the square root of 9, which is 3. And so this is just 11 times the square root of 9, or 11 times 3, which is 33. So x here is 11 square roots 3, and this one's 33. The main thing we have to do with these problems is start to reimagine, start to really process what are these numbers and how can we use them. While it's nothing crazy, like I'm dividing 22 by 2 and then multiplying square root of 3 times square root of 3, this stuff isn't crazy. Calculators handle this very well, but to really conceptualize what's going on here does take a bit of processing power for the brain. Okay, let's move it. Let's look at this next one. So this next one, I'm just going to write my reference triangle down here. This is supposed to be short leg square root 3, short leg times 2. And what do we see here? Well, what we have here is the square root of 21. But remember that we can break this up into its factors, right? So if you can think of 21 in terms of its factor, there is actually a square root of 3 in here. This is multiplies. This is actually 4 square root 7 times the square root of 3. Right? Because we can take 21, split it into its factors, and we can kind of get these. Okay, another way you could think of this is if we're multiplying the short leg to get to the long leg, then we'll have to divide to get from the long leg to the short leg, right? But so another way you could think of this, I'm going to write this down here, would just be 4 square root of 21 divided by the square root of 3. Now this is disgusting, but if your calculator can process square roots, this will in fact return the value for square root 7. But again, it's because of what's happening here. Square root 7, square root 3, square root 3. These two terms effectively cancel, and then you're left with that 4 square root 7. Either way, x is equal to 4 square roots 7, And then to get from the short leg to the long leg, we have to multiply by 2. So this is going to be 2 times 4 times the square root of 7, which is just 14 square root 7. So again, overall, I don't think that these are that bad. You just have to remember properties of radicals. The number can be split up into its factors under the square root sign, and then those can be split into their own square root signs. Let me make this look more like a 3. And then those can be split into their own square roots. This is the properties of radicals. This is a big thing to try and take away, because this is actually the mathematical principle that we are using when we are doing these problems. So that's the idea. All right, guys, thanks for watching.